Alright, so now that we've got our pets.db database file open, let's learn how to add a table to that database. So first off, here are the different columns that we decided would be in our table. And in order to make a table, we need to identify what the table would be called and what each of the columns would be called. And lastly, we need to determine what type each column should be. Now, types work a little bit differently in SQLite than they do in Java. The names for the types are slightly different, but the idea is the same. So let's take a deeper look. So SQLite uses a more general typing system. And to better understand what this means, let's take a look at an example. So for integers, there are many distinct types of integers. And in fact, there are over 6 different data types that can represent different sizes of integers. So for example, we could have a 1-byte integer, a 3-byte integer, or maybe a 6-byte integer. And translating that into SQLite, these data types could be grouped into a single category, or what's called a storage class in SQLite, and these would be grouped into the integer storage class. So you could use both the generalized storage class as well as the more specific data types as different types in SQLite. But I don't want you to get caught up in the technical details of different memory sizes. So we'll be using the main storage classes in this lesson. And throughout the course, I'll be using the words types and storage classes interchangeably. But if you're interested in learning more about the distinctions between these two, I've linked below a documentation to the SQLite data type information. So with that said, here's a list of the general storage classes, or different types, a single value in the SQLite table can have. So first off, we have null, meaning that the value is a null value. Next is integer. So this is a signed integer, things such as 1, 2, or 3. Following that, we have reals, and this means that the value is a floating point. So for example, 7.8. And next we have text, and those are things that are strings. And lastly here, we'll see blobs. So this means that the data is stored exactly as we input it. And examples of these are images or binaries. So from this list, you'll notice that our standard Java type booleans is missing. Now, SQLite doesn't have a separate type for booleans. Instead, a more efficient way to store booleans is to just store them as integers. What does this look like? Or for example, you can associate the number 0 with a boolean value false, or the number 1 with a boolean value true. In fact, integers are a great way to store information for columns where there are only a few options that could be in that column. So let's take a look at an example where we're associating integers with values, looking at our headphones example from before. Well, one of the attributes for headphones was styles. And let's say there are 4 different styles that the headphones could have. So it could be earbuds, over-ear, on-ear, or bone conduction. And one way we could have stored all these values is by storing them as text. Now a simpler way would just be to associate a number with each of these, and storing that number in the styles attribute. So first of all, storing a single digit takes up way less space than an entire word like bone conduction. And secondly, a long string of text can be less precise. For example, if we imagine people typing in on-ear or over-ear, it's possible they could misspell that entry. Now let's take a step back and discuss how we could choose a data type for each of the attributes of our headphones. So remember, first off, we had name, and that could be stored just as a text. Next, we had the price of the headphones, and we could see we want to store that as an integer. So it's often easier to store prices as integers, representing just the total number of cents, and then dividing it by 100 to get the dollars. So doing so ensures that you never get a nonsensical number, such as $33.787. And next we have style. Remember the different styles we had could be inner ear, over ear, or bone conduction? Well, in this case, we can store it as an integer and associate an integer value with the style. So say 0 for earbuds, 1 for on-ear, and so on and so on. Next up, we have in stock, and we want to store this as an integer. So in stock is essentially a boolean, meaning that we can store 0 for not in stock or 1 for in stock. And lastly, we have the description, and this can be simply stored as text. Alright, so here's your chance to practice this out. I've listed the column names from the pets table, And I'd like you to choose which of these storage types would be a best fit for each of these attributes. So there are a couple of things to note here. First off, for weight, we're going to simplify things and not be including the decimal point. Next, for gender, we're going to have 3 gender options, so male, female, and unknown. And lastly, for breeds, assume that there'll be lots of breeds, with pets of new breeds coming in every day. And notice in our storage class options, I've removed null, because there is no situation where you'll have a column that only has null values, much like you never have a variable in Java with a null type. Now the rest are possible answers, and go ahead and pick the storage class that you think is the best match for each of these attributes.